Assalamualaikum warahmatullahi wabarakatuh, and hi everyone, especially to the panel and judges. Today I would like to present to you regarding the field development of Glamour Merah field. But first of all, I would like to introduce myself. My name is Muhammad Zakri bin Muhammad Zaidin, the team leader of Dirgahayu Berhad. I'll also take the role of leading the Petrophysics and drilling disciplines. And with this, I would like to take this opportunity to introduce my team members.
Hi, my name is Shuhadha Binti Mama Khairi. I lead the Geology and Geophysics (GNG) and also the Economy.
Hi and Assalamualaikum warahmatullahi wabarakatuh. I'm Harith bin Aimiros. For Dirgahayu Berhad Field Development Plan, I'm assigned as a group leader for Reservoir Engineering and Facilities Engineering.
Hi, my name is Aqilah Binti Rahman and I'm the production technologist and also the HSE lead for Dirgahayu Oil Company. Okay, firstly, for the field summary, Glamour Merah field is located at Block SB 1812 in Sabah Basin at North Offshore Sabah, which is approximately 43 km from Labuan and 130 km from Kota Kinabalu. This field is observed to be located near to Samarang field. The age for this field is identified to be Middle Miocene. The operator for this field is Petronas Cari Gali Sdn Berhad, with Japan Drilling Company as the drilling contractor. Glamour Merah 3 and Glamour Merah 4 were identified as the exploration well for this field. Next, for the regional geology, the field lies in the West Labuan Paisley syncline and characterized by the major north-south groove Maurice Fault, which is the major tectonic importance. Glamour Merah is believed to be deposited in the later part of Middle Miocene sand and has the characteristics of prograding delta with coastal particulate. The geological features of Glamour Merah field are primarily made from anticline and syncline structures with a high possibility of fault. These unconformities are due to the Maurice Fault plate shifts. In early Middle Miocene, it is observed that the deep marine shale deposition occur and the deposition of slope were developed in post-lower Middle Miocene. Okay, next for the stratigraphic setting. Glamour Merah is situated on the inboard belt close to the outboard and barram belts, and these are mostly Oligocene-Miocene clastic deposit. The sediments that make up these basins are erosion products of the fold thrust belt uplift. The depositional environment also changed from deeper coastal section to shallow section, which affected by the tectonic mechanism from the collisions of the major plates. The Sabah Basin begins with stage 4, originating from stage 1 to 3, which consists of strongly deformed pre-early Middle Miocene deep marine siliciclastic sediments. A petroleum system represents the 5 elements required to allow hydrocarbon accumulation in producing field. The 5 elements are seal rocks, traps, reservoir rocks, source rocks, and migration. Based on the core data report, it is identified that the claystone represents and acts as a seal rock due to its characteristics which have low porosity and low permeability. The main structural traps in West Sabah are fault propagation fault and fault anticline. The Glamour Merah formation has anticlinal features that produce from the growth of faulting formation and tectonic movement. The type of reservoir rock of Glamour Merah field is mainly made of possible interbedded sandstone with formation of thin shells of Nile reservoir. Source rock preservation in Sabah Basin was originated from terrigenous organic matter which said to have been deposited and concentrated in the marine compact intervals. Due to erosion, the migration of hydrocarbon in Gelama Merah move along the fault through the grain source rock and occurs in an up-dip direction movement. For the depositional environment of Gelama Merah 3 and Gelama Merah 4, the dominant shape is serrated shape or also known as saw-teeth with irregular pattern of gamma ray log based on the gamma ray reading. For both Sand Unit 1 and Sand Unit 2 in Gelama Merah 3 and Gelama Merah 4, the expected depositional environment for this field is fluvial floodplain, mixed tidal flat, debris flow and canyon fill.
Move on to develop correlations. So for this, we conducted develop correlation by using TagLog Slumberger software, mainly to analyze the connection of equivalent patterns in order to identify the lithology and the characteristic of the log. So firstly, we analyzed by using the gamma ray log, and it can be seen that Gelama 3 and Gelama 4 show similar pattern, where we can say that these two wells is under the same reservoir conditions. So from the observation, it can be seen that there are two possible sand unit, which we name as sand unit 1 and sand unit 2. The top of the sand unit for Gelama 3 is at depth 998 meter, while the base is at 1480, which is at the possible off water contact. For Gelama Merah 4, the top depth is 917, while the base is at depth 1350 meter depth. After the sand unit have been identified, the 2D cross-sectional area can be constructed further by using the ImageJ software. From the cross-section, the all-water contact were observed to be at 1480 meter depth. This can be obtained and correlate with the pressure plot, MDT pressure plot, which said to be the same, which is at 1480 meter depth. The thickness for sand unit Gelama Merah 3 is around 268 meter, while the overall thickness for sand unit Gelama Merah 4 is around 389 meter. Move on to the reservoir model development. So we construct this model by using the Slumberger software version 2017. So for this semester, we have to come up to static modeling. So for static modeling, it is mainly construct to give a better understanding of the subsurface of the reservoir that can define the petrophysical and property modeling, and later on we have to come up with the reserve volumetric estimations. So these are the steps on how to develop the static modeling. So firstly is digitize the structure map by using web digitizer. So we construct this map mainly to develop the structure of the surface model in 2D, 3D and also skeleton grade. So once we have obtained our surface model, then the coordinate of the Gelama Merah 3 and Gelama Merah 4 well can be plotted by creating a new well and insert the well data. After we have plotted the well, then the stratigraphic model and the correlation can be made. So from the observation by using Petrel software, two possible sand unit can be observed, which is the same as by using the TagLog software. Next is the petrophysical modeling. So this model is generated to give a better understanding of the hydrocarbon distribution for volumetric assessment of flow in the reservoir. So petrophysical modeling involves the upscaling of the rock properties such as porosity, water saturation and oil saturation. So as seen in this figure, the color legend at the top left shows the scale or value distribution for each of the properties. So in this picture, the first row shows the porosity modeling. The second row shows the water saturation property, while the third row shows the oil saturation property. So next is the property modeling. So it was done to give a more understanding on the volumetric of the interster zone of hydrocarbon, where it separates the hydrocarbon zone with the water zone with a surface of polygon boundary, as you can see in the red arrow in the slide. So last, for the static modeling, is to come out with the volumetric calculations. Move on to the volumetric calculation of gross rock volume. So the formula that we use to calculate the gross rock volume is equal to gross interval in meter times with area that we obtain from the image J in meter squared. So we calculate our gross rock volume in minimum, most likely, and maximum cases for both Gelama Merah 3 and Gelama Merah 4 well. So for minimum cases for Gelama Merah 3, it gives a total approximately 29 million acre foot. For GM4 minimum cases, around 17 million acre foot. For most likely cases, GM3 gives a total approximately 33 million acre foot, while GM4 gives a total approximately 19 million acre foot. For maximum cases, GM3 gives around 36 million acre foot, and GM4 gives around 21 million acre foot. Next is the volumetric calculation for stock tank oil in place, or STOIP. So the formula for STOIP is equals to 7758 times area that we got from the image J times with height times with porosity times with SO, and divide by the oil formation volume factor. Okay, so this time we also calculate for STOIP for minimum, most likely, and maximum cases. So the total STOIP that we get from minimum case GM3 and GM4 in total is approximately to 33 million barrel. For most likely case, we get around 43 million barrels, and for maximum case, we got around 54 million barrel. Last, for the GNG part, is the uncertainty analysis. So there are three factors that contribute to the uncertainties. The first one is the unavailability of the seismic data. So this has led to the difficulty in estimating the presence of fault on the field, and inaccurate result on the determination of the actual reservoir boundary. Second is the non-relevance data from the control map. So our control map zone is between 1,300 meter depth to 1,500 meter depth. However, our zone of interest for Gelama Merah 3 and Gelama Merah 4 that we get from the well log is around has already started at around 900 meter depth. Lastly is unavailability of the well test report, reservoir analysis, and core data report for Gelama Merah 3 and Gelama Merah 4. So this has led to unanimous and inconsistency in making decision for our well, which is Gelama 3 and Gelama Merah 4.
Next, I will be explaining about the Petrophysics evaluation of Petrophysics department for Dirgahayu Oil Berhad Field Development Plan. Petrophysical evaluation are important as the finding that can be used for the Reservoir and Drilling Engineering department. Okay, for the first parameter of the petrophysical evaluation is the findings of the water resistivity. The water resistivity, or RW estimation, can be determined at clean water zone at depth of 1,480 meters to 1,670 meters. Hence, the RG equation relationship can be used for this for the water resistivity findings, which is below is the formula of the RG equation, which is where SW is the water saturation, RT is the true formation of the true formation resistivity, RW is the resistivity of the water, and F formation resistivity factor. Next, after the finding of the water resistivity, the PCAP plot can be constructed using the data. PCAP plot is one of the methods that allows quick and accurate evaluation using resistivity and sonic logs. However, it is required enough heterogeneous porosity of the rocks. PCAP plot is a graph of porosity versus resistivity. From the PCAP plot, the relationship between the porosity and resistivity of the formation can be identified using from the gradient of the graph. Next, will we be moving on for the full log interpretation of Glaumera 3 and Glaumera 4. The well log is generated using TechLog 64 2015 software to determine Glaumera field petrophysical properties. Further analysis on the parameters and properties of the field can be made using calculation and further analysis. On the left hand side, the well log produced from the TechLog 64 2015 software are focusing on the interested zone. Interested zone has the high probability to contain hydrocarbon in the formation. From the well log, we can determine that there are contained two sand units, which is sand unit 1 and sand unit 2 for Glaumera 3 and 4. Glaumera 3 and 4 is connected, hence indicate one reservoir system that are connected to each other. The determination of the location or possibility of containing hydrocarbon in the formation can be made from the sand units. The sand units can be determined from the low reading of the gamma ray log from the data and from the well log. The sand unit have high porosity and high probability that have the potential to contain hydrocarbon and can store formation fluid such as the hydrocarbon itself and water or saline water in the formation. Next, to determine the presence of the hydrocarbon in the formation is by identify the high resistivity in the log due to the characteristic of the hydrocarbon which is unable to conduct electricity. Next, to determine the presence of the hydrocarbon in the formation is to look at the neutron porosity and density porosity log that can occur butterfly effect from the cross-section of the neutron and density log. On the right hand side is the summary of the full log interpretation of the Glaumera 3 and Glaumera 4, which what is the type of formation and also the depth that determine the sand unit 1 and sand unit 2. Next, for petrophysical parameters for Glaumera field, there are three important parameters, which is shell volume, porosity, and water saturation. Okay, for shell volume or VSH, the volume of shell is based on gamma ray log, where it uses the naturally gamma rays that can estimate the shell volume when the radioactive material other than shell is present, such as sand in the reservoir. On the right hand side is the formula of the VSH of the shell volume, which is GR log minus GR min divided to GR max minus GR min, where the log can be determined using the well log produced from the data. On the left hand side is a summary table of the average shell volume of the sand units for Glaumera 3 and Glaumera 4. Next, for porosity, rock porosity can be determined from one or combination of the acoustic log, density log, and neutron log. The measurement of this log is not only depending on the porosity but also the lithology of the formation, the structure of the pores, and the fluid in the pores. This determination of the porosity is influenced by the presence of hydrocarbon, shells, and carbonates. On the right hand side is the formula for porosity of density calculation, which is the raw matrix minus raw bulk divided by raw matrix minus raw fluid. On the left hand side is the summary table of the average porosity for Glaumera 3 and Glaumera 4 sand unit 1 and 2. And lastly, for the petrophysical parameters, which is the water saturation or SW. There are two methods of calculation can be used, which is Archie equation and Simonduk's equation. The calculation of water saturation is to determine the saturation of water in the sand units 1 and 2 for Glamera 3 and 4. On the table below, can be concluded for the average water saturation for Archie equation and Simondov's equation from the data. Next, for the petrophysical evaluation is the pressure plot and fluid context. The pressure plot is constructed using the MDT data provided on the left hand side to determine the location of the fluid context, which is in this case is the oil water contact for Glamera 3 and Glamera 4. On the graph, we can determine that the water oil contact is at 1480 meters depth due to the intersection between the oil gradient and hydrostatic line. We'll be moving on to the sensitivity analysis. The method of sensitivity analysis is being used cutoff analysis. Cutoff analysis is to eliminate the non-productive rock like shale. This is also to identify the net to gross or NTG, because this method will control and reduce the loss of porous rock volume while removing the non-productive rock. The cutoff analysis is analyzed using hydrocarbon pore volume or HPV method, whereby plotting graph of HPV versus shale volume and porosity. Below we can see the HPV formula, which is a hydrocarbon pore volume equal to 0.145 meter multiplied with porosity and multiplied with the saturation of oil, which is 1 minus water saturation. On the left hand side is two graphs for HPV versus porosity and HPV versus visual for Glamera 3 sand unit 1 as an example. On the right hand side is the summary table for the cutoff analysis for both sand unit 1 and 2 for Glamera 3 and 4. Next, for net to gross for petrophysical evolution. Net to gross, or also known as NTG, is the ratio of the porous rock over gross interval thickness, which means the interval thickness for each layer in the reservoir. The porous rock in the reservoir can be defined as the net sand thickness. On the right hand side, we can see the formula for NTG, which is net sand divided by gross interval. On the left hand side is the table for the NTG value for sand unit 1 and sand unit 2, Glamera 3 and 4. The conclusion for petrophysical evaluation, the summary table are being made for all the parameters gathered from the petrophysical evaluation process, which is the NTG, the V shale, the porosity and the water saturation. All the data also be made for probability analysis using minimum, most likely and maximum to determine the number or the probability of the value for each parameters in Glamera field. Also, the gross rock volume for GM3 and GM4 also can be determined using the probability analysis for minimum, most likely and maximum. The data gathered using the petrophysical evaluation or petrophysics department can be used further for reservoir engineering and drilling engineering process. That's all from me.
Okay, a brief overview on the reservoir engineering discipline. It consists of two parts. First of all is the analysis of rock and fluid properties. Part of the data were obtained during the core analysis and also the fluid study report, while the rest data were calculated using gathered recorded data and also some correlation. While the second part consists of Monte Carlo simulation, which conducted to calculate or predicted the value of properties such as water saturation, permeability, rock compressibility with respect to P10, P50 and also P90. Basically, this is the temperature gradient plotted for both gelama merah 3 and also gelama merah 4. The data were obtained from the log data available and also the core analysis report. And next we will proceed on the pressure gradient. This is the pressure gradient plot using MDT data given for both gelama merah 3 and also gelama merah 4. Both wells were combined due to gelama merah 3 and gelama merah 4 existed within the same reservoir system. The gradient for both temperature and pressure be further used to determine other fluid properties using the correct correlation. Depth datum is the depth measured from the surface until the depth where wellbore flowing pressure existed with the reservoir fluid from the reservoir to the surface. So depth datum is very important to be determined in order to conduct proper planning during the production phase. As you can see from the table, the depth of the 1390 meter and also 1350 meter for both gelama merah 3 and also gelama merah 4 will require external force in order to lift the reservoir fluid from the wellbore to the surface for the production purpose. Based on the data given, there are two types of fluid existed within the reservoir, which is water and oil. Thus, the potential or possible drive mechanism existed within the reservoir system is the depletion drive mechanism and also water drive mechanism. Depletion drive mechanism, also known as DDI, is the depletion drive where oil expanded after a certain pressure drop, allowing fluid or oil to be further reduced for a certain period of time, while the water drive mechanism, also known as WDI, is the present bulk of water from nearby aquifer enter the reservoir system, pushing the oil upward, allowing oil to be further produced for a certain period of time. However, this WDI only apply if the reservoir is attached to aquifer with sufficient magnitude or meet a certain requirement. As mentioned previously, this is the fluid properties, which is oil properties and also water properties. The data calculated and graph plotted previously were used to obtain the fluid properties. Part of the fluid properties also obtained from the core analysis and fluid study report, and all the data were recorded and summarized in the table in this slide. Also, the method were listed in the table. Now we will proceed on the solution gas oil ratio and also the formation volume factor plot for the reservoir system. The data were obtained from the core analysis report, and after the graph was plotted, as we can see, the graph undergoes changes after it reaches a certain pressure drop, which is the bubble point pressure. The bubble point pressure is identified at 2014 psia, and the RSO or solution gas oil ratio changed from increasing to uniform after it meet the bubble point pressure, while the formation volume factor changes from the increasing to decreasing after it reach bubble point pressure. Okay, we will proceed on the capillary pressure. This is the capillary pressure plotted based on the core analysis report. Imbibition is the process of absorbing wetting phase, which is water into the porous rock, while the drainage is the process of absorbing non-wetting phase, which is oil into the porous rock. This capillary pressure plotted will be further used to determine or measure the correct pressure to be applied during the production phase. This is the graph of relative permeability also obtained from the core analysis report. Based on the graph, the blue color represents the relative permeability of oil, while the orange represents the relative permeability of water. This graph is very important to be plotted in order to determine the right water saturation in order for the oil to flow through the formation to be produced. And from the graph we can see that at water saturation of 35%, the non-wetting phase, which is oil, has the highest relative permeability, while the wetting phase, which is water, is ceased to flow. This graph usually being used during the production planning phase. This slide shows the fluid composition of fluid within the reservoir system. The composition were obtained from the fluid study report, and the ternary diagram were plotted using the fluid composition obtained. And as a result, we can see that the fluid within the reservoir system consists of heavy component, which is C11 and above, that cover 93% out of 100 fluid components. And this fact also was supported by the oil gradient from the pressure plot, which show 0.38 psia per foot also lies within the heavy oil pressure gradient. This is the phase envelope for the fluid in the reservoir system. The phase envelope were plotted via Aspen HISIS by inserting the fluid composition and also the fluid properties. By considering the temperature of reservoir at 155 degrees C, we can see that the fluid is within the range of black oil or shrinkage oil system. Last but not least, the simulation of Monte Carlo, which were applied for rock and fluid properties such as porosity, rock compressibility, water saturation, and also permeability. First of all, the data was prep, mean and standard deviation and average were calculated respectively. Then the data was inserted into the system and the simulation was run. As a result, the normal distribution graph was obtained and the probability value range from P0 until P100 was obtained. All the results were recorded, and the table is the summary of the data for P10, P50 and also P90. Now we reached the end of Dirgahayu Berhad presentation for Glamour Merah field development. Sorry if you face any inconvenience during our presentation. Thank you for lending us your ear. Feel free to ask if you have any inquiries regarding our field development. Thank you.